Hi guys, today we are starting with the new unit which is differentiation. In AS level last year, you must have learned the basic formula for differentiation which involves x raised to power n type functions, means just a simple algebraic function which was valid, means differentiation of that function was valid for any values of n. That exponent could be anything, whether it is rational or it could be fraction, decimal, positive integer, negative integer. Okay. This year, as we are studying some new functions, and all the function we will study trigonometric, all the 6 trigonometric functions we have already studied, log function we have studied, exponential we have studied, right? So how to differentiate all these functions? There must be some way and some formulas to differentiate this. So before uh, differentiating some new functions, let us understand the first topic, which is the product rule. Means if any two functions are in multiplication, how to differentiate those two multiplied functions. Okay, because sometimes it is easier to multiply those functions and apply the basic rule of x raised to power n, right? And of course, those two functions has to be algebraic if you are multiplying. If two multiply, let us say x into cos x. So if you are multiplying this x with cos x, it is in multiplication. So how to differentiate these two different functions in the sense that they are of different categories. One is trigonometric, one is algebraic. If both the functions are algebraic, then sometimes it is easier to multiply those algebraic functions and then obtain a final expression, simplified version, which can be solved, which can be differentiated using your x raised to power n formula. Okay. So your first topic in this is differentiation. Let us start. Product rule, sorry. So the product rule says that you have been given a function y, which is a multiplication of two functions given by u and v. Okay, so u is a function of x and v is also a function of x, right? And these two are in multiplication. Then what this product rule says, that derivative of this y with respect to x is you keep the first function as it is and differentiate the second function, and plus you keep the second function as it is v and differentiate the first function. That should be, I think, u. Yes. Okay, or vice versa. Means you treat first function as a constant and differentiate the second function, then write a plus sign and then differentiate the first function keeping the second function as constant. Okay, this is your product rule. This is very easy, right? Unlike integration, because integration of two product or the integrating the product of any two function is slightly more challenging or more complex, that we will study in further calculus. So for now, this is your product rule. So let us take an example how we can apply this. That here it says that y is 2x plus 3 into x square minus 5, and using the product rule you have to multiply. Why it is saying that you have to use the product rule is because first function is algebraic, which is linear, and second is quadratic, again algebraic function. So I can differentiate this without using the product rule, using your basic differentiating formula of x raised to power n. You can multiply this 2x with x square, you will get a cubic term which can be easily differentiated using x raised to power n formula, right? And same you can use the same formula you can use for other terms also. Okay, but here we have to apply the product rule. So I will treat this 2x plus 3 as my u function and x square minus 5 as my second function. Both the function can be algebraic. Okay, so how to differentiate this is that dy by dx is keeping the first function as it is, which is 2x plus 3, right, treating this as a constant function, and then differentiate this x square minus 5 with respect to x. So x square minus 5 derivative is just 2x. Okay, then you apply a plus sign and then keep second function x square minus 5 as it is and differentiate the first function, which is 2x plus 3. So derivative of 2x plus 3 is just 2. Okay, now you can simplify this. Please do not leave the answer here only, although answer can be obtained like this, that you have differentiated. It is just that you are doing simplification. Okay, so 2x into 2x is 4x square plus 6x plus 2x square minus 10. So this is 6x square plus 6x minus 10. This is your final differentiated function. Okay, very easy, very simple. Okay, let us take another example. We have to differentiate y is equal to 20x into x minus 1 raised to power 6. Again, first function you can treat as 20 raised to power x, second function you can write as x minus 1 raised to power 6. So its derivative is, first function you can differentiate keeping the second function as constant. So derivative of 20x is just 20 and x minus 1 raised to power 6 as it is, plus now you have to keep the first function as it is and then differentiate x minus 1 raised to power 6. Now this x minus 1 raised to power 6 can be solved or differentiated using chain rule, right, that we have learned in last year in AS levels, right? Writing x minus 1 as some variable t, then this x minus 1 will be t raised to power 6, and then differentiate this will be 6t raised to power 5, and again put the value of t as x minus 1. Okay, so I can directly differentiate this x minus 1 raised to power 6 with respect to first x minus 1, which is 6 into x minus 1 raised to power 5, and again differentiating x minus 1 with respect to x now, whose derivative is just 1. Okay, so this is your derivative of x minus 1 raised to power 6, which is 6 into x minus 1 raised to power 5. Now you can simplify this. How you can simplify is, you can take out the common as 20 multiplied by x minus 1 raised to power 5. This term I can see that 20x and this x minus 1 raised to power 5. Okay, these two, this product is basically common, not 20x, it is just 20. Okay, this 20 and x minus 1 raised to power 5, it is in both the terms. So I can take this outside. Inside the bracket you will have x minus 1 for x minus 1 here, and here you will get as just 6x plus 6x. Okay, so this is 20 into x minus 1 raised to power 5 multiplied by 7x minus 1. Okay, so this is your derivative function. Okay, very easy. Again I am repeating, product rule, keeping first function as constant, differentiate second function, write a plus sign, and then differentiate the first function keeping the second function as constant. Okay, next topic is quotient rule. Means if two functions are in the division, they are in the fraction form. Okay, so what is the formula for this? You have to remember this formula. Remember in the sense that without using the MF19, although these product rule and quotient rule, they will be provided in MF19, but for the sake of easiness and for the sake of speed, you have to remember these formulas. Okay, so what this quotient rule says, that if two functions, same functions means u and v, which are the function of x, then dy by dx is that we will first square the denominator. Okay, it is slightly harder to remember the formula. So we will first square the denominator, v square, and then keeping this v in the numerator as a guest. This is how I remember. Okay, keeping the v means your denominator function as a guest in the numerator, and then differentiate this your numerator, which is du by dx. Okay, then we will forget about our we will forget that this v will be our guest, then we will punish this guest. Okay, punishing means, what I mean to say, that I will apply a negative sign. Okay, and then again I will differentiate this v. Okay, applying a negative sign and then differentiating v. Okay, so first treating this v as a guest, differentiating du by dx, apply a minus sign, keeping u as a constant, and then du by dx. It is just opposite of product rule. Okay, means keeping v as constant, differentiate your first function, but here we have minus sign. Okay, and if there is a minus sign, there is a difference between which term you have to write first and which you have to write second. Okay, if you interchange this u dv by dx and then writing v du by dx after this, answer will be negative. Okay, so this sequence has to be taken care of, right? So first we will keep v as constant and differentiating the numerator one with a minus sign, keeping u as a constant, and then differentiating the denominator function. right? But this we will do after squaring this denominator, right? So let us do simple example. It says that we have to differentiate this using the quotient rule, and if it doesn't say that we have to use the quotient rule, then it is implied that since two functions are in fraction form, we have to apply the quotient rule. So let us do this. Dy by dx is, I will square the denominator, okay? So 3x minus 1, I'm squaring it, right? Keeping this as a guest in the numerator means write 3x minus 1 as it is and then differentiate the numerator. So d by dx of x square plus 1 we have to differentiate. So derivative of x square plus 1 is just 2x. I'm writing directly, okay? Now apply the negative sign and keep numerator as constant. So x square plus 1 as constant, and then differentiate the denominator, which is dy dx of 3x minus 1 is just 3. Okay. Now differentiation you have done, you have to simplify also. All right. So 3x into 2x is 6x square minus 2x, then minus 3x square and minus 3. Okay. In the denominator it is just 3x minus 1 whole square. So this is 6x minus 3 is 3x square minus 2x minus 3 upon 3x minus 1 whole square. This is your dy by dx. Okay. So just a quick revision. Product rule and quotient rule we have done, right? U du by dx plus v dv by dx. U dv by dx plus u plus v du by dx, sorry. Then the quotient rule, okay? Squaring the denominator, keeping the denominator as a guest, differentiate the numerator, then apply a negative sign, keep u as a constant, and then differentiate your denominator. Okay.